Good morning, everyone. So I hope you had a good sleep. This morning maybe we'll talk about nightmares. Nightmare that you pushed your application on a mobile phone and you realize that it has been compromised. So this is what we're going to talk about today. So a few words about me. So I work for Gradle, which is a build tool. And I'm not an expert in security. However, I think I'm an expert in the build domain, as in this domain, I think I can have quite good imagination in terms of what you can do with the build tools and what you can do to compromise whatever system. So I've been involved recently in the dependency management team at Gradle. So hopefully tomorrow, Friday, so we'll have the release of Gradle 6.0. And it involves a lot of dependency management features that we've been working for the past 2 years. Previously, before that, I was working on the Groovy compiler. So I was employed to develop typically the static compiler for Groovy. Anyway, that's all about me. I would like to know a bit more about you. So how many of you are already Gradle developers or using Gradle? Maven? Okay. How many JavaScript users? NPM, Yarn, whatever. Okay, so there's a bit of an overlap. I mean, that's natural, right? Everybody is doing more complex applications. We have different stacks, and you have to deal with different build tools. So this talk is about, this is just a slide for people who are going to read that slide deck from the web. Don't bother reading that, but this talk is about really, in general, what you can do with the build tool. It's not focused on Maven, it's not focused on Gradle. You can do that with whatever build tool you have, right? So let's just get started. And the warning and the frightening aspect of this talk is, you should know actually who you're facing and who is your enemy in this world. And you have two different kinds of enemies. One is just casual hacker that is just going to have some fun and try to hack your company just because it's fun to do that. But the reality is that you have nation-state actors there. So think about Russia, China, North Korea, United States. I'm pretty sure any country is doing that. So be aware that when we talk about security here, it is real actors and real people with a lot of money that can do something there. So let's just get started with just this analysis. So this has been made by my colleague Jonathan. So he's been involved in the recent disclosure of an attack a vulnerability in Zoom. I don't know how many of you use Zoom every day, but it was a vulnerability that let you actually access and do remote code execution via Zoom. So he's working for Gradle, and he did an analysis of the security adversaries that you have on NPM. And the reality is that almost a quarter of all those security adversaries are actually about malicious intention. So that's huge. I mean, usually what we were used to as developers is that you have a security vulnerability in your application or your library, but that's not intentional. That's because you misused the Java serialization protocol. Well, there's a talk about that. It's because, you didn't protect yourself about path traversal for a network request or whatever. But a quarter of those malicious things are malicious. So intentionally doing something to compromise your application. So another example, not in the JavaScript ecosystem, because it's always easy to target the JavaScript ecosystem. NPM is not super centralized compared to Maven. So Ruby has the same issue. So they recently discovered 11 Ruby libraries, but in those only 11 Ruby libraries, there were already 18 vulnerabilities. But it's not a random vulnerability. It is a backdoor, a software backdoor. So this is something which is intentionally aimed at introducing other software sneakily. So in this case, this is, quite okay for your organization because it wouldn't compromise your intellectual property, whatever. This was just about Bitcoin mining, so just about money, right? So just for the story, this happened to me. Not in the Ruby world, actually it was in the JavaScript world. So I used to write some web pages back then, 20 years ago, and I was using some JavaScript things. And I just kept at this error, and then I finished doing some web thingy things when I think it was Scriptaculous back then, something, if it reminds you something. And that was all I knew about JavaScript. So recently I had to do a website for a friend of mine. And he told me, I need this thing on the web. Can you do that for me? And that was the GDPR, cookie banner. So I was, I don't know how you do JavaScript now today. So let's go and find a library to do that. So I searched on Google, and the first link I found took this, it looks quite legit, so let's copy and paste this library and to introduce that into the web page. And guess what happened? Well, every user going to the website was starting mining Bitcoin. So, first link in Google, the library was compromised. That's the reality today. So, be aware of that. And this is not an easy task to realize. And this is just statistics. If you get one dependency in JavaScript world, in average, you get 80 transitive dependencies from that. 80. So 1 to 80. The ratio is just huge. And you might think that this is actually something that is specific to the JavaScript ecosystem. It's not. This is a real dependency graph. Right? So this is from the Java ecosystem. This is a customer of ours. And don't bother trying to figure out what the dependencies are here. The important thing is that there are thousands of different libraries being included, either directly or transitively. The interesting thing about this graph is that you can find some kind of clusters of dependencies. So this is interesting, but the reality is that if you face a dependency graph of that size, you're unlikely to be in control of everything. There are many, many things that you don't control. So how can you protect yourself in this case? This is actually quite difficult to do that. So the big difference, and something that really changed between 10 years ago and now, is that hackers don't try to hack directly something. They take different means and they try to be sneaking into whatever code you write. And the JavaScript example is just a simple example, but basically now what they are doing is that they're targeting companies like Gradle, companies like SunType or whatever. They are trying to compromise all the companies which provide some element in the supply tool chain. So again, all the links are going to be in the presentation later. You can go on those articles that are really speaking. The problem for us and the problem for you is that we have to protect ourselves because the attacks are indirect. And let's just start with a simple example that was recent, so last year. Anybody heard about the CCleaner attack? Okay, so not many of you. So how many of you are using Windows? Okay. Unfortunately for you, you have to use tools like CCleaner, right? So CCleaner is just a tool to clean up the registry, Windows registry. I'm using Linux, so I don't know much about that. But there are many different tools in Windows like CCleaner that have this mechanism of automatic updates. So last year, or maybe the year before, I don't remember exactly the date, it was bought by a software company, and they got this present that CCleaner was compromised, and it was compromised using the auto-update system. So every developer, every user that was using CCleaner suddenly got something that looked like official, because they didn't have to download that from Google or whatever. It was just an update of the software, and this update contained a backdoor software called Shadowpad. And what Shadowpad is basically something that lets you log, do some keylogging, or introduce other systems. And what the hackers did there is actually using Shadowpad to install remote access, remote desktop access control system. And by night, when nobody was working, they did something on the computers. So the something here is that the software, so the malicious software was downloaded, I think, by more than 2 million people. But in the end, the hackers only cared about 40 of them, and not because it wasn't possible to do more. It was just because those 40 people were the one they were targeting. They were using that to introduce themselves into some specific companies that they had targeted. So they knew that using CCleaner, they would probably get into someone in the company who had this software installed. So it was installed in a financial company in Russia, and I don't remember the other one, but there were different companies targeted, and the intent was really to steal data and maybe do more. And recently, Microsoft has been facing the same problem, which is that they have a software development toolkit, and you develop mobile applications with that, just like the Android toolkit, whatever. And this, again, was compromised. So it's not clear how it was compromised, something that it was exactly the same Shadowpad thing that was used to do that, but hackers managed to introduce malicious tool in the tool chain from Microsoft. And again, this wasn't done to compromise Microsoft. It was done to compromise other systems. So it's always transitive, if you will, right? So what they've done is that they modified the compiler for Microsoft, and then developers started shipping their applications on mobile phone, and to do that, they were signing the applications, so they were effectively signing malicious applications. So on your mobile phone, you could have an application that was totally compromised with a backdoor, and the developers would not know, because they trust, obviously they trust Microsoft, right? So this is the new world that we are facing today. So what it means for us, a build tool company. So as I said, there are many, many different things that you can do with a build tool. And we like to say internally that in practice, the build tool is a security issue by itself. This is something that allows you to execute random code. I mean, we have no control on whatever you do in your build file, right? So whatever the execution environment of the build tool is, there is some security issues there. So going back to the Java world, what are the potential attack vectors that we can find? So the first one is obviously the distribution itself. So you download Gradle, you download Maven. This is a zip. Yeah, you have to be aware that maybe this zip is not what you expected it to be. For Gradle, who knows the Gradle wrapper or used the Gradle wrapper already? Maven wrapper? Okay. 2 or 3. So we'll talk about that later. Plugins is also a good attack vector, and we have something like the plugin portal in Gradle from Maven. I don't think there's a plugin portal, but it also introduces a number of things. So plugins in the build is totally obscure for you. When you apply a plugin, who knows what this plugin is really doing? So it's just like a library that you integrate. This one, repositories, again, we're going to talk about why repositories for dependencies can be a pretty cool attack vector for hackers. Obviously, on dependencies, the local file system is too. So I'm guessing most of you already use Maven Local. Who knows if you have a virus on Windows, gets into this, changes the jars, how do you know that what you're going to ship doesn't have a virus included? This happens. And this is also why one of the reasons that the typical virus scanners actually do check those jars, right? It is because the local file system is easily compromised, but it comes at a price. The performance is just crazy there. I mean, if you have to scan everything. Who knows about the build cache in Gradle? Okay, so we'll talk about that. External services, of course. So, let's take a simple example. Imagine I am a hacker and I want to compromise your CI infrastructure. How do I do that? So, this example is using Gradle because as an open source company, it's even easier to attack us because, everything is public. So we like to do that in Gradle. We have pull requests, we use pull requests internally, and obviously we don't merge the pull requests before they pass the whole pipeline of tests. So we have just checking we cannot merge if the CI status is not green. We must check the compilation phase, check that you did contribute a license agreement. Then we have performance tests, etc., etc. So lots of different phases, and we do that on our own CI infrastructure. So for the record, we're just using TeamCity, but it could be Jenkins, Travis, whatever. What Travis? Yeah. So the easiest way for me to do that is, okay, I create a pull request, I do something, and I ask you to check, right? And because you trust me, you just click on the button, you run all the pipeline and go. Now, during the build, I'm mining Bitcoins. Could happen. This is super easy. So, a variant of this one is, no, I won't run that directly on the CI server. So I'm going to download that and check out your branch and run it locally on my laptop. But then instead of the CI server being compromised, this is my laptop which is compromised as a developer. And this can be even more problematic because you use that every day and you can seed whatever is in the company, so your repositories, you can even go to CI, so it's much easier to spread the malware in the company if you have access to the developer machine. So this is really the last guard that you have. As soon as someone has access to your machine, basically you're fucked. So, yeah. So how do we prevent that from happening? So first of all, this wasn't obvious for different, open source projects that we've worked with, but really the first thing that you have to do is to review the code before doing anything on CI. So it may just be looking at the sources that have been changed and look if there's anything suspicious there. Sometimes it's not obvious, right? In particular, if someone is changing a plugin version or just saying, yeah, I'm upgrading this library to this version because I'm facing this bug or whatever. I mean, we're good people, we trust them. But should we really trust those people that you don't know, right? Maybe they actually have compromised this plugin before. And maybe the upgrade is just for you to introduce this compromised plugin into your build. So it's always super hard, and you have to trust people or not. But really the first step is look at the code before, and then maybe you can try to do that. But that's not enough, because as we said, yeah, look at the source files, they look okay, this library has been upgraded. Let's do that. Let's run the CI checks. Okay, so I'm doing the CI checks, but I need to do something more. I need first to do this CLA, contributed license agreement stuff. So I don't trust really you, but I need for different reasons. So one is just legal, make sure that you have the intellectual property on this piece of code that you're submitting. The only one is I need to know about you a bit more. So CLA is a way to do that. You can check actually who is the contributor. So GitHub makes it quite easy. If someone just did one submission in his whole lifetime, maybe that's a bit suspicious. Could happen. I mean, we all start somewhere, but yeah, just check that. And then only when you think it's good, try to do it on CI in isolated build, so disposable build agents. So it means, well, everybody is doing that nowadays, but everybody has containers, Docker, whatever, etc. And it becomes the rule to do that on CI too. And that's an interesting thing just from the security point of view, because you isolate the build, and isolating, well, is obviously a good thing. So if you do that, there are going to be some problems I'm going to discuss later, but that's a really first good step for security. The other one is, I was mentioning the CLA, but something you can do, which is nice with GitHub, because it shows you that all the commits you can find typically in the Gradle code base are signed. And this is not really about signing because it's cool. It's about telling who is the author of this specific commit and trust this origin. So it is about proving the identity of the author of the code changes. So this is super important, and it's actually quite easy to set up if you're using GitHub. They even have a page to explain to you how you can do that. So do this, and actually in Git you have an option to automatically sign all your commits. So that's quite cool to do it. It's quite important for legal reasons too. So again, the origin of the code is important. So to come back on this topic of CI and disposable containers, what is the problem with this approach? And that's a practical problem that we are facing. So as always with security, it's not free lunch, right? Security is hard, and as you add more security, you have to make compromise. And one of those issues is that as soon as you start using disposable containers, you are likely to explode your build times for multiple reasons. So I often mention that, but everybody is doing builds in containers those days. So when you see the download numbers of whatever popular library you use, just take it with care, because every container is going to download that again and again. Or, well, you use Gradle and you have plugins, and in Gradle, when you have a build source plugin, it's going to generate the Gradle API jar, which takes maybe 20 seconds on Travis to do that. So it's 20 seconds that you're going to pay on every build, even if, well, that's something that you have done before. So this is not cool, because you're wasting time just setting the environment instead of building. So for those who use the Gradle daemon on CI, that's usually a good thing, because the performance of the Gradle builds improve as you execute more builds over time. But yeah, if you have disposable builds, well, there's no point in using the daemon there. Just disable it. The last point that I wanted to mention is that even if you do that in the Docker container, actually a single vulnerability in whatever layer of the Docker container is enough to gain access to the host. So this happened already in the past, so be aware. Don't think that because you are using isolated Docker images, you are actually safe. This is not the case, right? You just add something, so it's safer, but it's not safe. It's never safe. You're never safe. So we have performance issues because we execute all our builds into containers. So, well, everything is isolated, relatively safe, but I have kind of a problem now, is that my AWS build has multiplied by 10, or actually the feedback loop has increased just because it takes more time to run the builds. So the developer productivity is going down. So you have techniques to mitigate those You cannot mitigate all of those. One of them is using Reynolds price, but what is more important for us is to talk about the bill cache, which is a really nice tool to actually mitigate that. And the idea with the Gradle bill cache is that you can actually reuse the outputs of the tasks from different agents, different builds, even local builds, even builds running on CI, share the results between the different containers. So what happens in usual when you have a CI build is that you have different builds, and they share a lot in common. Like you have one build that is going to run all the compilation phase. You have a different build that is going to run the test. You have a build that is going to do all the check style and quality checks or whatever. And you have one running integration tests, maybe more of them. But all of them have lots in common. I mean, they all need the jars. They all need to compile, to download the dependencies, etc., etc. So the build cache is something interesting because it would share all those between the nodes, right? So you have isolated, but then you have something which is on top of that, which is giving all those isolated containers the common artifacts between the different builds. So it helps. However, we're not dealing yet with the dependency downloads with the build cache. So it means that if you don't have typically a repository, a local repository, a mirror on your CI infrastructure, then you're going to download everything again and again. So the good news is that we're working on this topic, and in future Gradle 6, that's something we're going to provide some ways typically to share the dependency cache between Docker containers, so something that lots of users have been asking for. So sharing in a safer way. All right. Let's talk about a bit about Maven Central, JCenter. So we like to think that as our comments in the Java world, like this is where you download the dependencies from, most of the dependencies from. So you have different things there. You have checksums, SHA-1s, whatever. Bad news, MD5 is unsafe, SHA-1 is no longer safe, so if you have lots of money, you can actually bake a SHA-1 signature that is exactly like the one you have on a repository, so it's not safe anymore. And you have signatures, but signatures are ASCII armored, and the ASCII armored system, the format actually requires a checksum itself, and the checksum that can be used there may be unsafe. So all of those that you have are unsafe. Cool. So what do we do with checksums? Usually the checksums are used to check the integrity of an artifact. So you get a jar, you look at the checksum. If the checksum is the same, well, I'm safe. This should be exactly the artifact that was produced, right? So this is about the contents. So in Gradle 6, what we add is the SHA-256 and 512. So this is going to be by default, and even on Maven Central, those are going to be published, because those are still safe. For how long, I can tell, but still safe. Another interesting thing is that the checksums that you have on the repository can be compromised. So it's easy. If you have access to a repository, you can obviously change the artifact, but also the checksums. And we've seen that in the past. We even have cases where the artifacts on different repositories are not the same. And who do you trust? It's hard to tell, right? So the good news is that there are lots of projects that use a good practice there, which is they put their checksums on a different server. So you shouldn't trust the one that comes from the repository. You should trust one that is on a different server. So typically you download a dependency, you have the jar, and then you go to the website. It tells you what the checksum for this dependency should be. But it's different hardware, and the checksum is written in a different place. So one of them may be compromised. You don't know which of the two is. But it's much harder for a hacker to actually compromise the two systems at the same time. So the good practice is to have your checksums separated from the repository itself. So checksums in the repositories are good, but not enough for security. Another interesting thing. So Maven Central is a quite surprising. So you have lots of checksums which are actually broken on Maven Central. So we don't know. Is it that the checksum was wrong when it was uploaded? Is it that the checksum is actually correct, but the artifact was compromised? Nobody knows. So JFrog and JSanta did something interesting there. What they decided to say is that the source of truth is the artifact. So actually, when they serve you the SHA-1 and MD5 signatures, this is generated on demand. So this is not what you uploaded. This is actually what they compute from the artifact. So that's not real files. Those are checksums computed on the fly. So be aware of that. So different repositories, different strategies. So never really trust what you see on a repository. In Gradle, so the Gradle wrapper is the thing that lets you wrap startup Gradle build just without having to figure out how to download the distribution, and it's about reproducibility, etc. So the wrapper comes with its own checksum, which is published on a website. So the first step that you can tap there is to actually verify manually the wrapper checksum itself, but then once you've done that, it has an interesting thing is that it's going to check the signature of the distribution itself after. So you have to trust the wrapper manually, verify your checksum, but once it's done, just add the checksum of the signature in the properties file, and Gradle is going to verify itself. So the distribution is going to be checked. So that's already a good step in making sure that what we provide to you is actually the real thing. And then we have this notion of signatures. So we have checksum and then signatures. The signature is really about proving the identity of an artifact. Well, the one who produced the artifact. So it's about the origin. Typically, yeah, they use pretty good privacy for that. The problem is that it's much harder to check. So how many of you already checked real signature for any of the dependencies? Okay, so not many of you. And that's not surprising. That's super hard to do. Well, if you don't understand how it works, you can do check signature, and then you have this that is going to tell you, yeah, the signature looks good, but actually it's written, but I don't trust the source. So the signature is good, I don't trust the source. What does it mean? I mean, it's super hard. So, yeah, there are lots of issues with signatures. The keys are sometimes lost. I mean, you have your keys on the laptop, then laptop crashes, keys lost. Happens every day. You can have real hackers doing real signatures. Yeah, I'm happy to sign. Why wouldn't I? I mean, I can create as many signatures as I want. And as I was mentioning, yeah, the signatures also include checksums, and those checksums may be wrong. So signatures are not super easy to check. But you have tools to help you. So in Gradle today, it's using a plugin. So the plugin we recommend today is the checksum dependency plugin, which is quite nice. And it allows you to specify a configuration file where you actually can put the signatures that you check and the SHA, different signatures, well, the different checksums that you want to check to. So it's quite interesting because what it does is also checking the plugins, which is not supported by other plugins. You have different plugins that do that in Gradle, but this one is the only one which is capable of verifying the plugins themselves. So use this one. Gradle 6. Something is going to introduce that natively. So we're working on this topic, which we take seriously. So you will have soon a native checksum and signature verification in Gradle. Just mentioning that this plugin actually doesn't check the metadata files. So you have your POM file and IV file or whatever, it doesn't check that. It's only about the artifacts and only that. So if you use Maven, I found this one, so I'm not a Maven plugin expert, but this one is also doing some kind of signature checking. So yeah, check it out if you're using Maven. But again, it doesn't support checking the metadata files, so who knows about the dependencies? I mean, metadata is the thing that is going to explain what the transitive dependencies is. So you can check the artifact, but you wouldn't know anything about the transitive dependencies. Are they really the ones that you wanted to have? Who knows? Third-party distribution. So maybe some of you are using Linux typically. I am, and they provide the tooling, and you do, I don't know, apt-get install Gradle, and you get the Gradle version branded as Gradle 560, and what you get? Who knows? This is not the real distribution of Gradle. This is something that they baked, right? So you have to be aware that when you use the distribution from a Linux distribution or whatever, this is not the real thing. What they do is that they build everything from source. They even change the dependencies, so it's not the same as the official dependencies. So they have their own checksums, etc. They have different bugs because they don't use the same dependencies. So they do that for a good reason, but just be aware if you can prefer the official releases because you know exactly what's in there, and we trust, obviously, ourselves. So yeah, do that. Let's talk a bit about repositories. So I mentioned that you can have different repositories with different metadata, and this is an example. So we found this dependency in Eclipse 1, which was published with different metadata on Central and JSON. And guess which one is the right one? Well, don't know. I can't tell you. So what happens is that you can have malicious repositories introduced. So typically in the past, Bintray, I don't know if you already use Bintray, allowed you to publish anything on any graph coordinates. So you could pretend to be a legal dependency there. And this happened, of course. So someone did that, and you can read this blog post, it's super interesting, but what happened is that someone realized that his application, his Android application, was doing something fishy. It was consuming much more resources than it should. And he realized that because he had the Bintray repository declared in his build file, actually he was getting a dependency which pretended to use the same graph coordinates, but it was compromised. So it wasn't using the one from Central, but one that was published on Bintray. So they fixed that, but yeah, this is the kind of things that you can have if you introduce extra repositories in your builds. The second one is the typical man-in-the-middle attack. So if you use HTTP instead of HTTPS to communicate with the repository, well, you are vulnerable to the man-in-the-middle attack. So change it now. Gradle is actually deprecating HTTP support. So all our services now redirect from HTTP to HTTPS. Nexus is going to do the same. Well, Nexus Summertime is doing the same for Central. Maven is going to do the same. So look at your build files and change HTTP to HTTPS. This is super important. There's a plugin for Gradle that can help you, built by the Spring team. You can check this out. That's quite easy to install. Who knows about the GitHub package repository? Okay, so this is a tool that lets you define your own Maven repositories, NPM repositories, whatever, directly on GitHub. And what is problematic there is that as you multiply the number of repository source, you potentially increase the surface of attack for all your dependencies. So we discussed with them, and in the end what this decided is that the custom repositories that you can define there are going to be authenticated by default. So you won't be able to add a repository and download that from random, because you need the credentials to access those repositories. So it's only for private use, basically. So for Maven, how many of you use Maven again? You are all vulnerable with that. And that's super easy. That's the easiest attack you can do. So in Maven, you declare repositories, right? And you assign them with an ID. So if I want to hack you, I'm going to use ID central in one of my repositories. And what Maven is going to do is that as soon as it finds the repository transitively, it's going to use it. I don't have to declare it. You're going to use my artifact, and because I declare a repository, it's going to use it. And I can pretend to be central, and I can change the URL. You won't notice. So Maven is totally vulnerable to this attack, which is replace whatever transitive dependency with what I want. So they do that, And I was discussing with them yesterday, so they're going to remove this feature from Maven. So the good practice is actually what Gradle does. So in Gradle, the consumer is responsible for defining all the repositories. So we never use the transitive repositories declared there. You have to repeat, because you have to trust the sources of your artifacts. So declare on the consumer side every repository that you use. Another interesting with Gradle is that you can do actually repository filtering, and this one is even better because there you can say, for this specific repository, I'm going to look for those specific groups or artifacts, etc., etc. So you can say, in this repository, these are the modules that I'm going to fetch, and nothing else. And typically, something that we discussed with the Sonotype guys is that you have all super private projects, right? Top secret, whatever, but you all use Maven Central, and what happens? Well, you ping Maven Central with your private group ID, whatever, and a super secret project, and Sonotype knows about that. I mean, they know that you have this. They don't serve it, but they have all the information. So you leak information about your environment to external services. So you can avoid that with repository filtering. So you can say, hey, actually, for this com.my company, this is only going to come from the Maven repository I'm defining here. So you can filter whatever comes from what. So much better for security. It also has the good effect that you can avoid some problems with ordering of repositories, like what I mentioned, when you have JCenter and Central serving the same, well, you can work around and saying, yeah, I'm going to serve one, use this specific repository. Again, we always say that at Gradle, but the life cycle of a dependency or an artifact doesn't end at the moment it's published, right? When we discovered CVE, it's always after the fact. It's always after that you discover that you have a vulnerable thing. So how do you deal with this information that you get after the fact? Well, you discover bugs, you discover vulnerabilities, you discover bad metadata, and we need to deal with that. So one way to do it with Gradle again is these rich versions that you can declare, and one is interesting, it's saying reject there. And you can say, I'm using something within that range, but I reject those versions because I know that those are vulnerable. And this is information that you can declare in the build script, but it can also be provided by an external plugin. So typically, if you use security software like Snyk or whatever, they have services that provide a list of the compromised dependencies. So you can use that to introduce that dynamically into your build and reject dynamically some versions which are vulnerable and you should never use them. So this is interesting, and by doing that, actually, Gradle is graph-wide, so it means that whatever the transitive graph resolves, if ever it found that in the graph, it would reject it. So build would fail, typically, and tell you, yeah, you have to do that. You have to change this dependency. So I was mentioning at the beginning how you can abuse external services on the build cache, and the build cache is just an example. I mean, you could do that exactly the same if you have a local artifactory, repository, or whatever. The build cache is just an example. So I have here write access to the build cache, and my laptop has been compromised. So I have the key to push to the build cache. So what I can do is actually write a custom client there to the build cache and push an artifact which is compromised using a real SHA-1 key, which is the key that we use to store something in the cache, right? So I'm going to push something to the cache saying, for this SHA-1, this is the artifact. And because we're mates, my colleague here, Louis, is going to fetch that from the cache. He gets the artifact, and his laptop is compromised too now. So this is just an example how you can easily abuse external services by either doing just a man-in-the-middle attack, whatever. So be careful whenever your build contains dynamic thing like access to an external service. Yeah, who knows what it's going to do? And the problem is maintaining that over time. Actually, it's much harder. So to fix all those problems, well, some of those problems, There is one approach that is often referred to, which is the reproducible builds approach, and the idea is that you need your build to be fully reproducible, but byte to byte. And there are a number of problems with that. So typically dynamic dependencies, so you have in your build, you declare, I depend on this range, I depend on 1+, whatever. You run today, tomorrow it's going to be a different dependency, different outcome. So different bytes. And declared inputs to your tasks, or the typical thing. I mean, who doesn't like to have a timestamp? I mean, we all put the timestamps in the version file because that's cool. We can show it, yeah, build that, whatever. But as soon as you have a timestamp, well, the build is not reproducible. So it means that I build here, Louis is building from his laptop, we get different outputs. So how can we trust the build if the output is different from 2 different executions? We can't. Compiler bugs. So that's as simple as that. Java has a compiler, Groovy has a compiler. There was a bug in the Groovy compiler where the order of the fields was written differently because they were using a hashset. Yeah, so it means that different executions can just introduce different bytecode. So that's a problem. So how can you approach that and make your builds reproducible? When one way is to think of that differently and go I like to call that the Apache way, which is only sources matter. So they tell you the only thing that you should trust is the sources, right? Nothing else. So we give you the sources, we give you the build, and then you build it yourself and trust whatever you build. The problem is that all those builds also have transitive dependencies, and how do you trust them? So there's a missing piece in there. What about the transitive dependencies? And interestingly, if you're familiar with the Apache Software Foundation, when they call the binaries, the jars or whatever, they don't allow you to have that on the Git or whatever. But they also say that those are convenience binaries when you build. So when you download from Maven Central, this is a convenience binary that you get, not something that they intended for you for consumption. We all do that, but this is not the real thing. You should build from source. Well, this is not super convenient. So another way is the Google way, where actually they say, hey, we also only trust the sources, but we have no binaries whatsoever. We always rebuild everything transitively from source. Well, unless you're Google, you can't do that. I mean, it doesn't scale. I mean, nobody can do that. So this is a bit of a problem in how will the reuse. So we have to make compromises there. And you can go on the reproducible.org website. It gives you some hints on how to do that. With Gradle, you have different options. So one is that you can enable dependency locking, which is already a first step. Like you have different dependencies, dynamic dependencies, but we guarantee that when you're going to build a month from now, it's going to be the same dependencies result, even if you have dependencies, dynamic dependencies. So a bit like what NPM locks do. Checksum verification is something that, yeah, you have to do, so make sure. And then the last one, which is probably the most problematic, is make sure that all the archives that produce are reproducible. So you can say, yeah, I don't care about the timestamps of those files in the jars. All the entries must be in a consistent order, which is a bit of a problem in Java ecosystem because you have to have some entries first in the jar file for the application to load faster. So again, compromises. What do? Do I want my application to run fast or start fast, or do I want to have security? Yeah. And even if you do that, yeah, again, you can have compiler bugs and you can't fight against them. So something interesting is that this is something that is considered by some companies that we work with. So the idea is that you trust this company, this company, this company. They all build your application. If they all come with the same binaries, you can reasonably think that this is safe. That's the idea behind this. Thank you. That's all I had today. I'm happy to take questions, but probably after, because I'm running out of time. I'm going to paste all these links on my Twitter account, so go read all those articles. They're really, really nice, and I hope you enjoyed that. Thank you. I have time maybe for one question. Yeah. So GitHub starts running the builds, and how can you prevent that from happening? Well, you can't. If you set up the GitHub hooks, then it means that you want them to have that. I'm pretty sure there can be some things with the new GitHub actions, so only if you do that or add a label, then it would trigger the builds, something like that. It's pretty smart that you can do what you can do. Oh, by the way, I have stickers, t-shirts if you want. Yeah, you can go grab a t-shirt. Thank you.